Hey YouTubers, welcome to the Cyber Overwatch channel. I am Pragmatic One. In this video, I will be doing a walkthrough of the HackTheBox CozyHosting vulnerable host. I will provide a walkthrough of reconnaissance through post-exploitation. This will include performing port scanning, service enumeration, session hijacking, OS command injection, hash cracking, and privilege escalation. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. Also, for more free content, please regularly check back on www.cybersec.com. CozyHosting is a vulnerable host created by Commander Cool. The Linux OS is running a vulnerable web app. It was created to allow users to practice ethical hacking techniques. This virtual machine is accessible from HackTheBox. I went ahead and started my target host CozyHosting. After launching it, it usually takes about a minute to start. As shown in the HackTheBox console, the target host now has an IP. If my end goal is to exploit this host and get root, I'll need to get an understanding of what is running on it. This will require me to start with information gathering in order to determine what ports are open and what services are running on them. There are several port scanning tools available like MassScan or RustScan, but for my active information gathering purposes, I am going to use Nmap due to its built-in network traffic sensing capability, which tends to make scans more accurate. I'll run the following commands shown in the CLI. In general, since I am trying to figure out what ports are open, I'll first want to scan all 65,535 ports using the -p- switch to look for services listening on non-standard ports. Looking at the Nmap scan results, it appears that Nmap detected 2 open ports running on the target host, port 22 SSH and port 80 HTTP. With Nmap scan completed, I analyzed the results. I can see that under service info, Nmap noted the OS as Linux. Based on Nmap detecting the OS as a generic Linux distribution, SSH service running, and the service banners showing Ubuntu, this seems like a logical assessment from Nmap. The first service I'll look at is port 80. Initially, when I try to browse to the website hosted on port 80, of the target host, I basically get page cannot be displayed. One thing I noticed on most HackTheBox lab systems that host websites is that you will need to add the IP host name to the hosts file on the pentest system. To resolve this, I'll run the following command shown in the CLI to add the IP host name to my Kali's hosts file. After adding the IP host name to my Kali's hosts file, I refresh and the site displays. Now that the site is viewable, I'll need to start investigating this site to see what I can find. I'll first start by running fuff as shown in the CLI to crawl the site for hidden pages while I manually review the site. Fuff completed and found index, login, admin, logout, and error. In general, I try to run at least a couple of similar tools to verify my results when I am enumerating a host. To validate my fuff results, I'll run dir search as shown in the CLI to see if I get different results. Looking at the results, I can already see that dir search did find similar results to fuff. Dir search found admin, login, logout, error, and index, and is still processing. While I was running fuff and dir search, I also began manually reviewing the page source. The only thing that was worth investigating was the index.html located on the page source of the main page that seemed interesting. When I clicked on index.html, I got a white label error page. As they say, Google is your best friend. After viewing the white label error page, I googled white label error page. This told me that this error message relates to Spring Boot. Looking at the Google results, I found the following page shown on the screen discussing white label error page customization. On the same page, it also referenced actuator endpoints and how the endpoints provide a lot of capabilities. Since the actuator documentation referenced endpoints, I did a little more research on Spring Boot actuator. I found some insightful information when I googled Spring Boot actuator. The information noted that you could do a lot with Spring Boot actuator, including configure your application. It also provided some examples of endpoints. I decided to Google search Spring Boot actuator endpoints and found this Spring Boot page that listed all the actuator endpoints and how to access the actuator. Reviewing the documentation, I just needed to add /actuator at the end of the URL. When I navigate to /sessions, it looks like a possible session ID for someone named Kate Anderson. I'll document the web address for later. It's always good to document everything during recon to go back later and do more deep dive with the information you've gathered. Next, I'll review /beans, and as can be seen on the screen, it exposes a lot of information about the application running on the target host. Reviewing the information from the beans endpoint, I can see the application encrypts the password using decrypt. Okay, so I move on to /health, and it just shows the status of the application. I move on to /env or environment, and there is some information displayed, but it looks like the values have been sanitized, so nothing useful. The final endpoint I review is /mappings, and it looks like there might be some interesting pages to review, like /admin. There's always room for enumeration, but with the information I've gathered, I think I'll move on to testing the web application. Based on the information I did gather, I'll check the admin page. I just need to manually enter the /admin as shown in the address bar. When I hit enter, it looks like I get redirected to the /login page. I reviewed the page source source and there is nothing useful. If I open up the developer's tools and go to storage, I can see it displays a JSession ID. Based off of my notes, I have what seems to be a username, K Anderson, and what looks to be a session ID. Since I have developer tools open, you can see my session in the /sessions endpoint as unauthorized in comparison to the session that says K Anderson. I'll replace the JSession ID with the session ID found on /sessions endpoint. It looks like replacing my session ID with K Anderson's session ID allowed me to hijack K Anderson's session. The page loads and it shows me logged into the admin dashboard with K Anderson's account. I was able to validate that /sessions endpoint exposed user session cookies. Reviewing the page, it looks like it's a vulnerability scanner of some sort. It references Cozy Scanner and appears to be authorized to connect to other hosts using the connection settings fields on the page. Since I have the ability to enter hostname and username for connection settings, let's run some tests. I'll open Burp Suite to intercept the traffic to see what info I can gain. Originally, I tried 127.0.0.1 for the hostname and K Anderson for the username. When you look at the request, you can see /execute SSH along with the session ID and my input. When I forwarded the request, I received an error message. The host was not added, host key verification failed. I received an interesting response when I entered just the localhost 127.0.0.1. In the response, I could see the help menu for SSH. This may be an indication that command injection may be possible. I'll run netcat listener with the command shown in the CLI. -L sets netcat to listen, -N for no name resolution, -V for verbose, and -P for port. I'll try a reverse shell. I can find several options from Swisskey repos GitHub page. Payload all the things. If you navigate to methodology and resources, then reverse shell cheat sheet.md, you can find several options for the reverse shell. I'll stick with a basic bash reverse shell shown on the page for my reverse shell payload. I picked a payload. I'll try running it to see what response I get. I run the following command shown in the request. When I tried to execute the command, I got an error message in the request that the username cannot have white spaces. I will more than likely need to encode my payload. Since I had payload all the things open, I went to the command injection page and found the bypass without space section that discussed $ifs. I googled $ifs white space bypass and found a Linux restriction bypass page on Hacktricks. Reviewing Hacktricks, I can see a reverse shell example. On the page it shows the payload has been encoded in base 64 and using $ifs to resolve the white space issue. Now that I have a possible way forward, I will need to encode my payload using the command shown in the CLI. The command basically echoes my payload. --i for interactive /dev/tcp is a special file that allows me to establish network connections using the TCP/IP protocol. 0 greater than &1 redirects the standard input to standard output. Base 64-W0 makes it so that it no longer adds new lines. I run the command and the output shows that I have a payload encoded in base 64. I take my encoded payload and paste it into the following command shown in the CLI. I encoded the reverse shell payload because it's transported through the web application. When I first tested it unencoded, it seemed to error out. Base 64 encoding tends to be handled better in web requests than binary data. It should then hopefully be decoded in the target host's CLI to execute the reverse shell. I added the $ifs to remove all the white spaces as noted earlier because in earlier testing, I had received an error stating the host does not like white spaces. I add the semicolon to let the host know where the command starts and ends. Set my netcat listener as shown in the CLI before hitting submit on Cozy Scanner. When I check the netcat listener, I can see that it has caught a shell as shown in the CLI. From the shell, it looks like I am the app user, but just to verify, I ran the whoami command and I verified that I was the app user. I ran the ls-la command to see the contents of the directory. The only thing I see is cloudhosting.0.0.1.jar. During recon, I ran the cd/home command to go to the home directory. Once in /home, I did an ls-la. I can see a home folder for a username Josh. I got permission denied when I tried to access it. Here, I noticed a jar file in the /app directory. I'll download the jar file to see if there's anything useful. I checked to see if netcat was installed and it looks like it is. On Kali, I run the command shown in the CLI to run another netcat listener. I configure netcat to output any received data to CozyHosting.jar. On the target host, I run the command shown in the CLI. The -w tells netcat to basically wait 3 seconds. I enter my Kali IP and what file I am uploading to Kali. Once I ran the command, I went to /downloads folder for verification. It looks like I was able to upload the jar file to my Kali successfully. I have the jar file on Kali. I need to figure out a way to read the contents. Again, Google is your best friend. I found a page that referenced JDGUI. I tried running JDGUI, but it was not installed. Kali asked if I wanted to install it. I clicked yes and let it install. I ran the command shown in the CLI to open the jar file with JDGUI. JDGUI opened and it looks like I have access to the contents of the jar file. Under boot INF classes, I see HTB.CloudHosting, which looks promising. Under boot INF classes, HTB.CloudHosting scheduled fake user.class, there is a username and password. Upon further testing, it was Kate Anderson's credentials for Cozy Scanner web application. I was now able to log in directly to Cozy Scanner without having to do a session hijack. Further enumeration of the jar file, I found some Postgres credentials in boot INF classes application.properties. That looks promising. Based on the configuration info, I should be able to log into the Postgres DB for further enumeration. PSQL, I ran the following command shown in the CLI from the target host. -H is for the host IP, -P is for port. The Postgres configuration seems to show that Postgres is using the default port 5432. In the jar file, it showed CozyHosting as the DB and the DB user as Postgres. I get prompted for a password and I enter the password that I gathered from the jar file. After I hit enter, it looks like I get a prompt, but nothing else. I type \L and press enter. I get a list of databases as shown on the screen. I can see a database called CozyHosting. I type \C to change to the CozyHosting database. Based on the response, it now says I am connected to the CozyHosting database as Postgres. I type \DT to view the tables in CozyHosting. I can see hosts and users table. I typed \D users to view what columns the users table contains. I can see the username and password columns. I ran the select all from users SQL query to view all the information from the users table. One thing of note, make sure to type the semicolon at the end of the query or the query will not run. The command ran successfully and I was able to view the password hashes for the admin and Kate Anderson accounts. As noted earlier, I was able to see that the passwords were hashed in bcrypt. Knowing this will help me when I try to crack the hashes. I'll use Hashcat to crack the hashes. If you go to the examples page on Hashcat's wiki, you can view the variety of hashes Hashcat can attempt to crack, the mode number to use, and an example of what the hash looks like. In this case, I will use mode 3200 for bcrypt as shown on the page. Now that I have the bcrypt hashes, I need to crack them. I'll run the following command shown in the CLI to attempt to crack the hashes. As shown on the screen, Hashcat was able to crack the admin hash as Manchester United. Now that the admin hash is cracked, let's try to log in as admin via SSH with the command shown in the CLI and see if it works. I get prompted for a password and I enter Manchester United. Unfortunately, that didn't work. I get an error message, permission denied, please try again. Admin did not work as a user, but earlier when I was enumerating the home directory, I did see a user account named Josh. I'll try logging in as Josh. Sure enough, it looks like the hash I dumped from the Postgres database was the password for the Josh account. Now that I'm logged in as Josh, I need to do further enumeration. I ran the ls-la command to see what's in the current directory. It looks like I can see the first flag, user.txt. I ran the cat user.txt command to view the hash for the first flag. I enter the hash into the HackTheBox console and click submit. I ran the sudo-l command and the output showed that the Josh account is able to run SSH as root. I go to GTFO bins and search for SSH and I can see that sudo is available. When I scroll down to the sudo section, I see a command I can try. I copied the command from GTFO bins and pasted it in the target host CLI. When I hit enter, I get a hash prompt. I verify that it's a root prompt by running a whoami command. Sure enough, I now have root. Now that I have a root shell, I change directory to the /root folder. I do an ls-la to see the contents of the root folder and I can see the final flag root.txt. I cat the root.txt file to get the root hash. Now that I have the root hash, I'll enter it into the HackTheBox console to complete this host. In conclusion, I wanted to do a little more detailed walkthrough than I normally do to kind of show that there are different paths you can take when testing a host. It's like getting into the cybersecurity field. You don't have to take the same path as everyone else, as long as you reach your goal. In this walkthrough, I highlighted a variety of techniques I was able to implement to go from reconnaissance to gaining root privileges on the target host. Executing these steps allowed me to gather the information I needed to gain a foothold on the target host through the use of session hijacking on CozyHosting web application. Once gaining access to the web application, I was able to execute command injection to gain access to the underlying OS as the application service account. With access to the database, I was able to laterally move by dumping hashes then cracking them. Now accessing the underlying OS from a standard user account allowed me to perform further enumeration to find a workable escalation path to root by exploiting security misconfiguration of sudo in order to gain a root shell and access the flag. Thank you for tuning in to this demonstration of HackTheBox's CozyHosting vulnerable machine. Thank you for also checking out the Cyber Overwatch channel. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. If you have any questions, please feel free to leave me a question in the comments, or you can send me a message from the CyberSec website listed in the description. Until next time, keep learning. The only way to improve is to keep learning. Pragmatic One signing off.